learn about the application of numerical method in civil engineering areas. But in this project, we will be more focusing on bisection method to determine the depth of a submerged object. Next, we will continue with objective and problem statement.
My name is Johannes Binti Roslan, AF 180135. I will read problem statement and objective. The objective for our project are to find the depth of the submersible by using bisection method. Secondly, to find the absolute relative azimuth area using iteration method. And thirdly, to determine the drag coefficient by using bisection method. The problem in our project is the floating ball has a specific gravity and radius, which is 0.6 and 5.5 cm respectively. Find the depth to which the ball is submerged when floating in the water. As you can see in the figure, from the physics of the problem, the ball would be submerged between x equal to 0 and x, where r equal to radius of the ball. That is x between 0 until 2r, x equal to 0 until 2, or x equal to 0 until 0.11. The equation that gives the depth of the submerged ball underwater is given by x cubed minus 0.165 x squared plus 3.99 to the power of negative 4 equal to 0.
Next, we will continue with Villa table.
My name is Siti Awanis binti Yusoff, AF 180110. I will present Villa table for this project. From this table, there are 3 facts that obtained from the problem statement. From the problem statement, the equation of water is given. From this equation, we can determine the root between x1 and x2 by using intermediate value theorem. Next, the specific gravity and radius of floating ball are given. From the information, we can determine the depth to which ball is submerged when the ball is floating in water by using bisection method. We also can determine the relative approximate error of the iteration that found by using the bisection method by using formula error. Lastly, the information given is the velocity equation for submerged ball in water. This information is to estimate the value of drag coefficient by using bisection method.
Next, we will continue with calculation part A and B.
My name is Yusoff. I will discuss about calculation part. For question A, find that whether there is a root exit between 0 to 0.11 from the equation by using intermediate value theorem. From the calculation, we get function of 0 equals to 3.993 times 10 power of negative 4. And for the function of 0.11, we get negative 2.662 times 10 powers of negative 4. So when the function of 0 times function of 0.11 is equal to negative 1.063 times 10 power of negative 7. Since function of 0 times function of 0.11 is less than 0, so there is a root in the interval between 0 to 0.11. For the question B, find the depth to which ball is submerged when the ball is floating in water by using bisection method. From the physics of the problem, the ball will be submerged between x equal to 0 and x equal to 2r, where the r is the radius of the ball. So we get the range of x is 0 to 0.11. After derived by using bisection method, we get the function of C10 equals to negative 2.88 times 10 power of negative 7, and it is less than 5 times 10 power of negative 7. Therefore, the root of the function is approximately to 0.06241. Thank you.
Next, we will continue with calculation part C and D.
My name is Ku Dongjie, number matrix AF180238, and I will discuss about the calculation for part C and part D. For part C, we need to calculate the relative approximate error by using the formula error as shown. So, for calculate the error, we had 3 interactions. For the first interaction, we estimate the root as 0.055. But however, for interaction 1, we doesn't have to calculate the formula error because we doesn't have the previous approximation. Interaction 2, we can get the estimate of the root equals to 0.0825, and then from there we can calculate the approximate relative error, which we get 33.33%. Last, we do the interaction 3. We estimate the root as 0.06875, and from there we get the relative approximate error, which is 20%. At last, for the part D, we calculate the drag coefficient by using the bisection method. We assume the drag coefficient value. We calculate the drag coefficient value as shown in the table. So since the F20 times F22 is smaller than 0, we can say that there is an interval between 20 to 22. From that, we can conclude that the drag coefficient of the FC is equal to C number 10, which is 21.8859.
As for the discussion, we can see that the depth of the submerged ball is 0.06241. As for the absolute relative approximate error, the first iteration, the error cannot be calculated as we do not have the previous approximation. While for second and third iteration, none of the significant digits are in between the estimated root because of the absolute relative approximate error is greater than 5%. 7 more iterations were conducted as shown in the table in the calculation part, and as for the drag coefficient, the answer that we calculated from the equation is 21.8859. In conclusion, based on this group project, we can see the relation of numerical method in civil engineering areas, where it is proved that the depth of a submerged ball can be calculated by using bisection method.